What's up, family? It is none other than your boy JGiddins, the father. As usual, remember to be positive, be optimistic, and keep positive people in your circle, as those three things are key to ensuring positivity is invited into your future. Okay? Now, I want to first off take a moment for anybody, because I know a lot of people not going to make it through enough of this video to know what this is about. So real quick, for the people watching this on the replay, this is going to be a lecture, which is an exposition on a specific topic given on a public forum normally, on quantum physics as well as frequency. Okay, the purpose of this lecture, well, the purpose of any video that I do is what I call the 3 I's, right? That's to inform, to provide insight, and to inspire. Okay, the purpose of this video is really to be able to make sure that you are familiar with what quantum physics is, you are familiar with how reality works around you, right? And what really inspired me to do this video was the fact that there's so many videos out there showing things like the clouds, things like the sky being peace and love to you, Midnight Maya. There's so many things out there showing, you know, these what we call phenomena, right? And everybody's commenting like, oh, what is this? Can this be real? And you know, and a lot of that is because of lack of knowledge and lack of insight about things. This video, and I apologize to everybody, and I'm talking just so I can allow some people to get in, you know, because I know I told everybody I was going to do it at some point. I told everybody I was going to do this live at some point between 3 and 9, which I know is like a big gap, but y'all got to understand, I have, like I said, I have 5 children, you know, 3 of which are, you know, in toddler/infant stage, so you got to bear with me. I actually was really close to not even doing this live. I really didn't even have, you know, like time to do it. But, you know, I'm gonna do it. I'm sitting in my bed. I got my little ones right here. So my apologies if y'all hear anything. And I'm going to go ahead and get through it. All right. I'm going to wait maybe about 2 or 3 minutes to see if I can get anybody in here. And let me just pin something here while we're waiting, right, for anybody to come in. Peace and love to everybody in here. What's up, Prokaryotic Mark? I know you said you was gonna come through. Let me tell you, brother, I'm gonna try to make this as quick as possible, because I know, you know, we can't really rush through this because it's kind of important, but I'm gonna make it as quick as possible because I know that, you know, a lot of people, it's late. You know, it's 9:35 where I'm at. I was planning on doing it at 9:30. I actually wanted to do it at 8, but things ended up, I was doing some stuff, and my son here can be a little bit, you know. All right. So I'm actually just going to go ahead and get started because a lot of people can watch it on the back end. Now, for anybody watching this back, I want to make sure that y'all understand that one thing that I always say in all of my lectures when we get started is that it's very important that you understand etymology, right? So anytime that I go into a lecture, and y'all will see this on my other lectures as well, I always like to reference etymology because this will show you the true meaning of a word. I want to give y'all a quick anecdote real quick, which is, you know, just like a short story that has a message behind it, to let you know the importance of etymology, right? So, and I've said this before, but I think it's important. So imagine that you and your family were in, you know, some sort of an extra dimension that you weren't aware of, right? You're in a different world. Say you went to a different planet, right? And you saw these beings there, and your child called these beings pigs, right? 100 years later, on that other planet that you were on, other people that were there would call those beings pigs as well, right? But when they call them pigs, they're not going to understand what you were referring to when you called them pigs. You know what I mean? Etymology would be the study of what you meant when you said pig, right? Because when you said pig, you were actually talking about a pig from our planet Earth, not the pig from their planet. You get what I mean? So all of these words that we talk about. What's up, Lot? What's up, everybody that come in too? One love to y'all. I'm just getting started, right? I'm just explaining the importance of etymology. When we look up the etymological definition of a word, it's really because we're looking to find out what the word truly means and what the intent of the word is, right? And I'm prefacing that because we're about to look into the etymology of quantum physics. Now, before I get into quantum physics, or before I get into frequency, which is really what I want to do, I really wanted to do a lecture on frequency, but I felt like I just wanted to touch on quantum physics real quick. Yeah, what's up, family? I wanted to touch on quantum physics just so that you can have, a basic understanding of what I'm talking about when we're talking about frequency. Because, we talk about frequency, we talk about vibration, high vibes, making sure you keep your vibes high. But, like, what does that mean? Like, a lot of people, they don't really understand, like, what that means. There's actually there's a metaphysical or quantum physical meaning when you say keep your vibrations high, right? So, let's go ahead and get into it though. First thing I want to do is, first thing I want to do is take a sip of my lemon water real quick. Give me a second. Actually, bear with me for a moment, because I'm about to send this out to, and y'all feel free to share the live with anybody that you want to. I'm gonna send it to, there's one person that actually, there's one person I want to tag that I know wanted to come in. So let me tag her. Give me a second. Alright. So I'm gonna give her a quick second to come in. She really said she was gonna join. What's up, Wyman J Productions? How y'all feeling? One love to everybody too. I know a lot of y'all may be noticing, and I commented this on one of my pictures, or one of my posts. And Locke, you may have noticed this too. A lot of y'all might be noticing that you hearing things in the sky. It sounds like something big. You hear something, it sounds like it's a big oversized aircraft or something, but when you look up, you don't see nothing. Like, you look and you like, yo, there's nothing there, but you hear it. And you like, yo, I know there's something there, but you can't see it. The purpose of this lecture is so that we understand why that is, because there's a scientific reasoning behind why that is, right? And I want to try to make sure that as many people get in here as possible before I get started. I'm gonna try to wait till we get to like either 9 or 12 people. We at 6 right now, which is a divine number, but I'm gonna try to wait till we get to like either 9 or 12 people. All right. So for anybody who watching this back on the replay, fast forward if you like for another minute or two, or however long it takes for us to get to that number. You said you went through that in a dream. Yeah. Dreams are you in another dimension. So, and it's typically like 4th, 5th dimension, astral realm. This is you. This is actually you, like the quantum physical you. That's why we're doing this lecture. The goal of this lecture, and I'm not gonna be able to. I'll be honest with y'all, because quantum physics is so deep that you can do a lecture on. You said, but I look up and seen God, my screen is cracked. I looked up and saw a fleet, I think that says. yeah. But the purpose of this lecture is really to kind of make sure that people are able to perceive things a little bit better and conceive things, because it sounds crazy when you say certain things if you don't understand the science behind it. You know what I mean? You say I be telling myself in my dream that I'm dreaming. Yeah, I mean, we have many different, realities, and we exist in many different ways that we just aren't aware of, because we think this is everything, because this matrix, we actually about to speak about what a matrix is anyway, on a quantum level, because a matrix is just a field of, like a field system of formulas, all together. Like, we'll touch on that. All right, so let's go ahead and get started, man, because we haven't really passed 7. You know what I'm saying? And at this point, I don't really want to wait that long, because this is an important enough topic to where if somebody wanted to be in here, they would have waited and they would have came in here. You know what I'm saying? And they can watch it back, so that's not a problem. Anybody come in afterwards, we'll make sure to address them then. All right. So when we're talking about, let's go ahead and get started. All right. Now, when we're talking about quantum physics, right, the first thing I want to do whenever we learn in anything is learn what something means, right? You don't want to focus on the definition. You want to focus on the etymological definition, because to define something is to actually hide something. That's what to define means. When you define something, you take away its fineness and you make it clump together and hard to see what it is. So you kind of like combine everything into one, so you can't articulate what it is. But when you look in the etymology or something, you figure that out. All right, but for quantum, right, the website that I like to use for y'all who may not know, the website I like to use is Atom Online, right? So I recommend that y'all get this website if you don't have it. I think they got an app too, but I like to just, you know what I'm saying? So we're going to type in quantum, right? Because I just want y'all to see what the etymological definition of quantum is, right? So what they tell you the etymological definition of it is, and this comes from the 1610s, right? But everything that you're going to notice is going to date back to Latin. Anytime that you studying, or anytime that we going into something that's deep, whether it be like cloning, eugenics, all that kind of stuff, is going to date back to Latin, or it's going to date back to ancient Greece, because that's where they date from. Like, they don't predate that. There's nothing that predates ancient Rome, ancient Greece, you know what I mean, in terms of the non-indigenous, which are those that created all of this, because we didn't use any of this, okay? And when I say we, I mean the indigenous being, carbonic beings, okay? All right, but so quantum comes from the Latin word quanta, right, which means as much as, so much as, or how much, how far, how great an extent, right? But we really want to focus on is what it means in science, right? So when we go down, or in physics, right? Bear with me, because I think they tell you what it means in physics down here somewhere. See, like the stationary state, right? Basically, what you want to know is that when you're talking about quantum physics, you're talking about what the initial, you said I was resting and it just so happened early in the rising around 3 to 6 a.m. I started casually, uncontrollably meditate, just laying there monitoring my thoughts towards my spirit from my body and cruise control. Right, exactly. That was a shift in your in the state of the quantum atoms inside of you, like the metaphysical you, but just know that quantum is the sum of what something is at its initial state, right? And that something we're talking about in science is gonna be atoms, right? Now it trips me out because I thought that they would have told us specifically. It doesn't show you specifically minimum amount of quantity which can exist, right? So just know that when you're talking about quantum, you're talking about the minimum amount of something, right? Now let's go into physics, because a lot of us think we know everything. Let's go back, because this tablet is so slow. Bear with me, y'all. Bear with me for a second, okay? This tablet that I'm using is so slow that what happens is I'll press something, and then all of a sudden stuff start moving that wasn't moving before. You know what I'm saying? This is one of those like free tablets that they just give you because they want to track you, and they want to have some way to have you be distracted in life. So they want everybody to have one of these, but it's not for any kind of like purpose of, Alright, so look, physics, right? So let's look up physics. Alright, when we look up physics, right, this is going to date back to what again, y'all? Latin. Everything's going to go back to Latin, because Latin is when everything started, right? This comes from the Latin word physica, right? And there's a book called Aristotle's Treatise on Nature in Greek, right? Remember I told you ancient Greece, ancient Rome, Latin. And Latin is what? A Romance language, right? Which means it's a Roman language. And Latinos is what you call a misnomer. There's no such thing as a Latino, okay? I just want to make sure y'all clear on that. There is no such thing as a Latino. Latin is a language, not a place, okay? So that doesn't make any sense. That's what they called all of the people in South America when they went over there and conquered that area, okay? But let's keep on moving. That was just a small little gem for y'all. But so physics is the natural science, right? So it's the study of the natural science of nature. And they've been doing this since Aristotle. Alright, I just want y'all to know that. Let me see if they go deeper into it. Hold on. Alright, so no, they don't really go deeper. Alright, so just know that the science of treating other properties of matter and energy, right? So basically they're telling you that it's the science of treating properties of matter and energy, right? All right. So in a nutshell, quantum physics is the study of peace to you, Mama Anunakai. One love to you. What's up, Chandra? I'm glad that you came in here. We just getting started. So I was just showing the etymological definition of quantum physics. But quantum physics is basically the study of the initial state that something is before other things happen, like the very minuscule level of everything. So before I move my hand, what is inside my hand that makes it move? What is inside of that makes it move? It's the most minimal state, right? So you're basically talking about subatomic particles and atoms, right? So that's what the study, that's what quantum physics is, right? Physics is the study of what we can see here in nature, and quantum physics is the study of the smaller in between that subatomic particles, as we call them. And as you see this, you'll understand why, like, you can see certain things but not hear certain things, and what dimensions are, and how that all works, because it all ties in together. But this is going to be kind of deep, so let me just hurry up. All right, so what I want to do, what I want to do to start, right, because there's a lot of so I would want to reference something for y'all called Natural Philosophy, but because I want to hurry this up, I'm not going to do it. But there's a book called Natural Philosophy, which was written by Aristotle, where he talked about all of this stuff. And he talked about nature and how to manipulate nature and all of that kind of stuff, metaphysics and all of that. I would just reference that for anybody who wants to go deeper and look a little bit deeper into that, okay? Now, with quantum physics, it's super deep. So, like, it's something that you could spend hours and hours and days talking about. But I think the best way for us to try to attack it is to start with quantum state, right? So anytime that you're studying quantum physics, and I'm going to be using Wikipedia for all of my people out there who like, oh, Wikipedia is wrong, blah, blah, blah. Listen, let me first off tell you this, okay? That is incorrect information. There is no better way to learn than Wikipedia, point blank, period. I'll sum it up for you. Wikipedia is not a source. It is a compilation of sources. Wikipedia is like if you took everything on the internet that's ever been available and crammed it into one place. I'm actually very surprised that this shit still exists and they didn't shut Wikipedia down, okay? Because Wikipedia will allow you to learn every fucking thing. Like, I don't even know why they have this, because there's no reason for school, there's no reason for work, there's no reason for nothing if you have Wikipedia, because Wikipedia can tell you everything, right? And it gives you sources. So if you prefer it in a book, I'll tell you where somebody wrote it down in a book so you can read what they wrote, if it make you feel better that it's written on paper. You know what I'm saying? Because all it is just somebody who said it and put it on paper. But look, let's keep going. So I feel like, what's up, Janelle? I'm glad you came in. I tagged you because I wanted you to be able to see this, right? Now, you alright, son? You okay? Alright, y'all. I got my son here too, you know, so bear with me, y'all. I almost didn't even do this lecture, right? Alright, so we're going to start with quantum state. Anytime that you are studying quantum physics, you're always going to start, you said they do change definitions though. So here's the thing, right? Whether they change definitions or not, what you want to be doing, and this is a quick side note away from the lecture, because I know people who are skeptical about Wikipedia, they don't maybe know how to use it. So regardless of if they change anything, you go here, right? You see this? These are resources. So this comes from, what they're referencing here is this. Cambridge University Press. ISBN stands for International Serial Book Number. This is the book that this comes from. So you don't get mad at Wikipedia. You get mad at Cambridge University, right? So you got to contact Cambridge University and say, hey, why are y'all saying this? Because Wikipedia is pulling this from y'all, right? On every page that you go on, let me show y'all, because I just want to show people, because a lot of people don't understand what Wikipedia is. They think Wikipedia is an actual place. It's not. It's literally just like a compilation of information. So you go to references, right? This is where everything on this page comes from. So for all of my people who like, I want a book, go get this book, okay? If you need pieces of paper, go get pieces of paper, okay? Go read Statistical Structure of Quantum Theory. There you go, okay? But me, on the other hand, I want to learn now, okay? I don't got time for that. I don't got time for books. I like information, not books, okay? Now let's keep on going. So look, in quantum physics, a quantum state is a mathematical entity that provides a probability distribution for the outcomes of each possible measurement on a system. Now look, this gets deep, alright? So what I'm going to do is, I'm going to read, let me just tell y'all what I'm going to do real quick. I'm going to read down to here. Okay, and I'm gonna explain what we read as best as I can for y'all till we get down to here. Then I'm gonna move on to atoms and subatomic particles real quick, go over those, and then I'm gonna go ahead and move on to frequency. All right. You said they guilty by association. Well, here's my question: who ain't guilty by association? Who you learning from? Where is it that you think you gonna go to that's not guilty by association? Because here's what happened. See, you about to take me off topic. I Ether. I don't know if you're doing this on purpose, but you're distracting. But let me just address you real quick. When you say they're guilty, you know what? I'm not even gonna do that. Listen, you got the right to say that. Yeah, they're guilty by association, guy. You got that. All right. So look, in quantum physics, right? And just so that y'all know what quantum physics is, let's see what they say, right? Quantum mechanics is a fundamental theory in physics that provides a description of the physical properties of nature at the scale of atoms and subatomic particles, right? So, okay, you said you just saying, hey, not a problem, bro. Listen, it's all love, all right? It's all love. So what they basically did was just say what I told y'all in a complex way, right? Quantum mechanics is a fundamental theory in physics, right? So a fundamental theory means a basic way of thinking, right? They use these big words, but don't pay that no mind. Quantum mechanics is a basic way of thinking in physics, right? We know what physics is. It's the study of nature, right? So it's a basic way of thinking about nature that provides a description of the properties of nature at the scale of atoms. So it's basically telling you the mechanics of how atoms work. That's what this is, okay? So in the mechanics of how atoms work, right? Because you got to replace these big words with what they actually mean, because this is how people get confused and intimidated. That's why I'm about to go through these and break this shit down. All right. But in quantum physics, right, which is just the study of the way atoms work, in the study of the way atoms work, a quantum state is a mathematical entity that provides a probability distribution for the outcomes of each possible measurement on a system, right? Now let's break this down. So a probability distribution just basically means what are the chances of something happening in a quantum equation, right? But let's see what they say, because they're going to make it sound complicated. I'm going to break it down. In probability theory, right, which means how probable it is for some shit to happen, and statistics, when they're talking about statistics, they're talking about previous studies that they've had. They're talking about like different types of statistics that they've done. You know how they do studies, right? They'll do different equations, right? So in probability... I appreciate you, son. Bear with me. Hold on, y'all. Hold on. Bear with me for a second. I'm watching my son, too. My son let me know that I got to change the channel, all right? I got to turn something on for him. Bear with me. I got to multitask here. Hold on. Son, what you want to watch? Listen, son. Listen. You're going to have to pick something. You're going to have to pick something. You're going to have to stick with it, okay? Because what I'm not going to do is keep on doing this every 5 minutes, okay? Because I'm in the middle of something, all right? So... watch this, okay? Alright, bear with me, y'all. Let's go back. Let me read this comment real quick. I have this inner carriage of letting go of all these 3D stipulations and fucking up shit quantumly for righteous cause. So look, alright, let's get back to it, y'all. Let's get back to it. Alright? Cause really, I'm just doing this so that when I get to what I'm trying to get to, it don't sound crazy. Alright? A probability distribution is the mathematical function that gives the probabilities of occurrence of different possible outcomes for an experiment, right? So all they saying when they say probability distribution, right, is like when you take a certain amount of atoms or subatomic particles. So we haven't gone over them yet, but like hadrons, quarks, baryons, electrons, these are subatomic particles. When you arrange them in a certain way, the chances of them acting a certain way, this is what that's talking about, right? So let's say like when you go to work, the chances of you coming home from work angry, the probability of that is based on who's coming to work, maybe what the temperature is outside, because you might get pissed off if it's too cold, maybe if you have to do a lot of work when you get to work, you know what I'm saying? This is the probability distribution, okay? You follow what I'm saying? If anybody don't follow what I'm saying, just comment and I'll keep going, or I'll explain it, all right? But let me keep going, all right? In quantum physics, because like I said, I'm not doing this for no reason. I want to make sure everybody follows so this shit don't seem complex. In quantum physics, a quantum state is a mathematical entity that provides a probability distribution for the outcomes of each possible measurement on a system. When they talking about a system, they talking about a quantum field, which is just like the area that you're working with, right? So let's say you had like a tote and you was working on what's being done with this tool. That would be the system. That's the quantum field, right? When they say measurement, let's see what they list that as. Because none of these words mean the same thing that you think they mean. Okay, when you're talking about science, you have to look that shit up because it's never what you think it is. Okay, measurement in quantum mechanics, right? In quantum physics, a measurement is the testing or manipulation of a physical system to yield a numerical result. Okay, so what they're saying is, let's say you had a quantum field. No. Let's say you had a quantum field of gas particles, and you put a flame to that gas, right? The box that you have those gas particles in is considered the quantum, that's considered the physical system, right? So the testing or manipulation of the physical system to yield a numerical result. The numerical result is going to be basically like, you know, whatever the count of the subatomic particles are, or whatever the chemical reaction is. Okay, we don't need to get deep into that. Again, I'm just going over the stuff basically so that when I tell you what I'm gonna tell you about frequency, it don't sound crazy and you can follow it. All right, so let's start again. In quantum physics, a quantum state is a mathematical entity that provides a probability distribution for the outcomes of each possible measurement on a system, right? So basically, a quantum state is it's a measurement of what everything that can happen with something. So if you have my hand sitting here, the quantum state of my hand is a measurement of everything that my hand is capable of doing from the state that it is. So if you light it on fire, is it capable of combusting? If you make it hot, is it capable of melting? All of those things, that's considered the probability distribution, which is based on things like temperature, all of that kind of stuff, right? Now, knowledge of the quantum state together with the rules of the system's evolution in time exhausts all that can be predicted about the system's behavior, right? No. Okay? So basically what they're saying, to break this down, knowledge of the quantum state, right? Everything that we just said, knowledge of the quantum state together with the rules for the system, right? The system's evolution in time exhausts all that can be predicted about the system's behavior. So what that means is that knowing everything about my hand in this quantum state allows you to know everything that my hand is capable of if you know the environment that my hand is in and what the rules are for the environment that my hand is in, right? So if my hand is in a box with hydrogen in it, right? Knowledge of the quantum state would be knowing what my hand can do, knowing what my hand is capable of, together with the rules for the system's evolution, right? Meaning, is everything okay? Knowing that, look, you see, I'm trying to do this lecture and there's a whole bunch of shit happening in the house. You see how stuff happen? So, together with the rules for the system's evolution. So what I'm basically showing you is that they can predict anything and everything. They can predict anything and everything that can happen by knowing the quantum state of something and the rules around that thing, right? Now let's keep going, because none of this is really super duper important. It's just more so that you know that they know this, so that you don't think that it's crazy or something weird when I tell you some of the stuff we're going to get to. Okay, now a mixture of quantum states is again a quantum state, right? I know that sounds crazy, but a mixture of quantum states is again a quantum state. They don't want the message to be heard. So look, when you say mixture, right, because nothing is what it means in science. When you say mixture, you probably think about mixing water and Kool-Aid, you know, water and powder to make Kool-Aid. That is a mixture, but that's chemistry. But when we talking about, let's look at this. So look, they're talking, this is metaphysics, right? Well, this is quantum physics, so it's a different meaning. So it's mixture distribution. And this is a part of probability distribution. So in probability and statistics, a mixture distribution is the probability distribution of a random variable that is derived from a collection of other random variables as follows, right? So basically, look, just understand that they're saying that if my hand is the quantum state here, and we know all of the variables that my hand can go through, and let's say we put somebody else's hand there too, that itself is a different quantum state in itself, because my hand and that hand together are going to react in its own fashion to create its own quantum state with all of those together. You get what I'm saying? And it's not overly necessary that you completely understand that. Just know, well, I guess you should understand it, but you don't need to know everything in and out about it. Just understand that, okay? And if there's anything anybody don't understand, comment it if you watching back, and we can go over it further, or I'll do another lecture on specifically mixture, because each one of these is a lecture. Understand that. I could do a whole lecture for an hour on each one of these. I'm just touching them so we can know that we're not crazy, all right? I'm reading down to here, and then we're going to move forward. All right, now, a mixture of quantum states is again a quantum state. Quantum states that cannot be written as a mixture of other states are called pure quantum states, right? So an example of that would be, let's say if I'm throwing a ball, right? Me throwing that ball would be a quantum state, right? The speed, the force times distance and all of that. Now, mind you, that's physics, because my arm is not considered quantum, right? My arm is not considered quantum. So me throwing a ball would just be physics, but I'm just giving you a concept to go off of. So if I'm throwing a ball, and that can't be changed. Now that can be changed because you can do things to maybe give me steroids. You can make the ball heavier. You can do things to change that. That's considered, not a pure quantum state. But if me throwing the ball could not be altered at all, right? And they're saying that because there are certain subatomic particles that cannot be changed. And that's why they're saying those are what you call pure quantum states, all right? We don't have to go too deep into that, just know, all right? Now, quantum states that cannot be written as a mixture of other states are called pure quantum states, while all other states are called mixed quantum states, right? We getting there, y'all. We're going to get the frequency. I know a lot of people like, what the hell? I don't want to hear the science shit. But I just want to go over it in general. For the people watching this back, you can skip forward to the end where I talk about like why you can not hear shit that you see. But I just want to cover this for people who actually care about knowing like the full science of shit. All right. A pure quantum state can be represented by a ray and a Hilbert space over the complex numbers, right? Now, I'm not going to go into a Hilbert space and ray because honestly, that's pretty deep. That's pretty deep. And I'll fuck around and lose us just pulling that shit up. But complex numbers you wanna know about. This is in relation to real numbers. And real numbers, like a complex number is like so this is supreme mathematics, essentially, like hitting there. A complex number is a number that's a part of a number system, right? So like let's say you had 2, 4, 6, 8, 3, 6, 9, 12, or 7, 85, 14, 92, right? The complex number is the element of that number system, right? So whatever it is, that's the difference. An example would be like E equals MC squared and shit, like an equation that has a number that's a part of that number system. We don't have to go into that. I just wanted to mention it to you. And forgive for all of my people who like, where'd that come from? Wikipedia don't know. They making all this shit up. Go contact, let's see who you can contact. Go get this book. By Griffith David. International Serial Book Number 978013111892892-8. Introduction to Quantum Mechanics. Go read that book. Some people need pieces of paper. Okay? If you need pieces of paper, go get paper. Read it on paper. Okay? Alright. Now, alright, let's go back. A pure quantum state can be represented by a ray and a Hilbert space over the complex numbers, while mixed states are represented by density matrices, right? Now, density matrix, right? This is where you get into a matrix. Now, a matrix, all right, let me see what they say real quick. In quantum mechanics, a density matrix is a matrix that describes the quantum state of a physical system, right? Now, a matrix is a system of numbers, right? When you're talking about a density matrix in quantum mechanics, those numbers are all equations. They're all like quantum fields and quantum states of themselves. Like, you know how in the Matrix, like when Neo was seeing everything, he was seeing all of these numbers, zeros and ones, right? Those zeros and ones in quantum physics would each be like, each one of those numbers would be a specific equation, right? So when they're saying a density matrix is a matrix that describes the quantum state of a physical system, they're talking about the entire system itself. So let's say like you had a brick, right? That would be a physical system, which is a systematic grouping of atoms together, right? So the density matrix describes the quantum state of that system. It just basically breaks down to you what all the variables are, what the what the different probabilities are and all that good stuff. All right, let's keep going, because like I said, we don't have to know all of this stuff in and out. I just want to show you that they know this shit. All right, I want to show you they know this shit and they study this shit. So when I tell you that your sky is fake, don't fucking think that they don't know this shit. Okay, it gets way deeper than this. I'm just showing you like this shit is real. All right, now, which are positive semi-definite operators. Now, this is a part of Hilbert spaces, and I don't want to get into that because that's a whole nother level. Like, that's raised spectrums and shit. We don't got to get into that. All right, once we get to here, I'm gonna stop and we're gonna move on to frequency. But like I said, I just wanna cover this so that y'all can have a brief understanding of what this is. Okay, bear with me for a second because I want to look and see. They froze my screen up. Hold up, y'all. Bear with me for a second. My screen just froze. Why is my screen froze? Can y'all still hear me? Somebody drop a 9 or something if you can hear me. Bro, why is my screen froze? Drop a 9. Can somebody comment something? Bro, why is my screen froze? I'm going to comment a 9 myself. I just commented and it's not even coming up. Bro, this is annoying me right now. I wish one of y'all who had my number could hit me and let me know if y'all can still hear me, because they blocked y'all. I can't see nothing that's going on right now. Let me do if you can hear me. Or somebody, let me pull y'all and tell me if you can hear me. Man, I can't even tell. This really annoys me. They did this. Look, I'm gonna keep on going, and if it turns out that it's not able to be seen, I'm gonna just delete the live and do it again. Fuck out of here. You know what I'm saying? I ain't about to. You know what I'm saying? It is what it is. I'll freeze my damn screen up. It is what it is, y'all. All right. So look, pure states are also known as state vectors or wave functions, right? So when you talk about a wave function, that's talking about that field, that area that I was talking about, like whatever, like when you're talking about physics or science or chemistry, you always have something called like a field. Like in chemistry, you have something called, or actually in physics as well, you have something called a magnetic field, right? And that is the area in which you're working with. So like this screen on this tablet, this would be a field, right? Because this is the area that we're working with, the space, right? It's also referred to as space, right? When you're talking about quantum physics, it's going to be called a wave function, right? So let's see what they say, though. I just wanted to explain it as best as I could. Bro, if y'all not able to see this, this is going to piss me off so much because my screen is frozen and I can't tell if nobody in here. And if I'm talking to myself right now, it's going to super duper annoy me. A wave function in quantum physics is a mathematical description of the quantum state of an isolated quantum system. So they're basically telling you that this is the numerical version. Let's see what it looked like, right? Yeah, so this is telling you like what the state, see, and the reason this is moving, right, is because atoms are always moving. Everything is always moving. That's what vibration is. Nothing is still, right? So a quantum state is always going to be representative of something moving. I bet you if y'all go back and watch the movie Transformers, after this lecture, you're going to be like, oh, them niggas was in there talking about that. Because this is what they was talking about, the quantum state of the robots and what they was capable of doing with the electrons. But let's keep on going so we can get down to here and then move on. All right, so pure states are also known as state vectors, right, or wave functions. And when they say vectors, that's talking about geometry, right? So if you were studying geometry, then you would understand what a vector is, and it's just talking about an angle in a specific area of the field that you're working with. That's so I don't want to look. It's really not necessary. Just know pure states are also known as state vectors or wave functions. The latter term applying particularly when they are represented as functions of position or momentum, right? So that's pretty much self-explanatory. For example, when dealing with energy spectrums, right? Now, when you're talking about a spectrum, you're basically, and for anybody who's commenting, oh, Goddess, yes, this is perfect. Do me a favor. Do you have a way to go into my live? Hold on, y'all. For anybody who watching this back, I'm gonna need y'all to skip past a minute. They froze my screen because I think they trying to make me not be able to communicate with people, and I can't tell if people can hear me. Can you go to my Instagram and just see if you can see me? Confirm for me. Give me 1 second, y'all. If y'all can see me, bear with me for a minute, okay? This should confirm for anybody watching this that they don't want you to know this shit. Because I do lives all the time. My screen don't freeze like this in my lives. Like my phone has completely frozen. And I want to look, and it's 111 right now. It's 1011, 111. That's synchronicity in numbers, numerology, gematria. You know what I'm saying? To confirm what I'm saying. But my screen is frozen. I can't see none of the comments. I can't see if nobody's in here. Yeah. You can hear me. Okay. My goddess just came in, and look, when you came in, it didn't even show me that you came in. So that's how I knew they playing with the live. But look, so whoever in here, one love to you. I appreciate y'all staying in here. Come in and out as much as you want to. Just know I ain't going to stop. I'm going to keep on going. They stopped me from being able to communicate with y'all because they knew y'all was going to be able to ask me questions and have me go deeper into it, anything that we want to. You know what I'm saying? But that's all right. The information going to be there for y'all to research further. Like I said, these are the books y'all can get, right? If you want to learn this stuff yourself, because it ain't like I'm showing y'all. That's why I don't understand why they freezing it. I'm not showing y'all nothing you can't get yourself. Look, Olenvo Alexander, International Serial Book Number 354042082-7, Statistical Structure of Quantum Theory. Go get that book, or just learn it here, but go get that book and read that book, and it'll show you all about what I'm talking about. So why are they trying to stop me? You know what I'm saying? Because the best way to hide something from somebody is put it in a book, huh? All right, so look. The latter term applying particularly when they are represented as functions, position, or momentum. So look, let's keep going. For example, when dealing with the energy spectrum of the electron. Now, when you're talking about a spectrum, right, an example of a spectrum is a rainbow, right? Let's see what they say here, though. A spectrum is a condition that is not limited to a specific set of values but can vary without gaps across a continuum, right? This is a portal. I want to say that again. This is a portal, right? Because when they're saying a spectrum is a condition that is not limited to a specific set of values, they're talking about dimensions. Values are different, like, arrangements of atoms. This is where sacred geometry and quantum physics match up, and you can have different. This is what CERN is doing. You know what I'm saying? I don't want to use too many key words that they're looking for, but look, a spectrum is so just know that that's what a spectrum is. So that's why they bring up a rainbow, because it's a rainbow is a spectrum of frequencies, because that's why you have all these different colors, because that's all frequencies are. That's all colors are, is frequencies, just vibrations of atoms at different paces, right? But let's keep on going so I can try to make this under an hour, so it'll be all under one. What did I do? Okay. All right, so look, let me read that again. We're about to stop here. For example, when dealing with the energy spectrum of the electron, so they basically talking about the potential energy of an electron. An electron is a subatomic particle that has no mass. That's what you really want to know, okay? The electron is a subatomic particle with a -1 elementary electric charge. Electrons belong to the first generation of the lepton particle, right? Now, lepton is a classification of a particle, right? I'm not going to go all the way into this shit. I'm just showing you that they go into this shit. But leptons are classifications of particles, because subatomic particles have classifications based on their behavior, and are generally thought to be elementary particles because they have no known components or substructure, right? What that means is there's nothing inside them, right? Like an atom has things inside of it, a proton, electron, and neutron, right? And other particles have things inside those, you know, axons, things like that. So let's just leave it there, all right? So I want to go into hydrogen atom real quick. Because I really just wanted to kind of, let me go into this. Hold on. What y'all gonna freeze up my laptop now? I mean, I'm gonna freeze up my tablet? What's going on? All right, there we go. Goddess. Goddess. Goddess, I apologize to keep calling you. When you in my live, can you see how many people in there? Does it show you? I think it does. Tell me how many people in there if you don't mind. Yeah, just look in there. All right, my apologies, y'all. I got to use. Listen, My apologies, family. I got to use my goddess to watch the live because they hiding from me what's happening. So I can't see how many people in here. I can't see if nobody commenting. I can't see none of that. So I'm actually going to have her like look at the comments. She in another room though. She doing something else, so I don't want to take away from her. 10. 10. My screen. 10 with me, so right. So if anybody comments something that you think I would want to know, can you tell me? I apologize, goddess, to have you have to do this. Oh, on the laptop. All right. Well, don't worry about it. All right. That's cool. Love you, guys. Anybody watching this back or watching this right now, just comment after the video is done, whatever comment you wanted to say, because I can't see whatever you're doing. All right. So hydrogen atom. Real quick. This is the element of hydrogen, right? And hydrogen is one of the most effervescent or one of the most available chemicals or elements in all of existence. Just know that, okay? So a hydrogen atom is an atom of the chemical element hydrogen. The electrically neutral atom contains a single positively charged proton and a single negatively charged electron. This is why it has no charge, because it balances out. The proton and the electron balances out. Yes, sir. Okay, bear with me for a second, y'all. My son has, son, what you want to watch that? You want to watch this?
I got your drink.
All right, I'll let you watch this. You can watch this. All right. Now, just know, all right, so my apologies, y'all. So look, proton charged electron bound to the nucleus by the Coulomb force, right? And this is just named after a dude. When you see these words, they just name these after people. All right, there's some dude named something Coulomb that they named this after, but this is the law that determines what the spin of an electron is, right? Because this is what determines the capability of an electron to travel and charge other particles, right? It's called the spin. It's normally like a 1/2 spin, and this is all determined based on like something called free radicalism, like the free radical nature of the electron. We don't have to get into all of that, but I'm just showing you this, okay? So just know that, all right? And all right, so let's move on. Like what I want to do, let's go to sub. Oh, I can't spell for a minute. Hold on. Sub. Goodness gracious, can you spell, brother? All right, let's go to subatomic particle, right? I just want to show y'all what a subatomic particle is, okay? Because y'all heard me say hadron and stuff like that, but let me just show you what it is, okay? In physical sciences, right? Science just means the study of. Physical, they're talking about physics. We already know what physics is. That's nature, right? So in the study of nature, that's what they saying to you. In the study of nature, a subatomic particle is a particle that composes an atom, right? We know what an atom is, right? Matter of fact, let's go to an atom first. I apologize. Well, I'm going to talk about subatomic particles when we didn't talk about an atom, okay? Listen, an atom is composed of, most of us know this already, an atom is composed of a proton, neutron, and electron. Let me see if they show you a model of it. It's called the Bohr model or something like that. I think it's called. That it kind of shows you. Okay, so this would be the nucleus, right? In here you have a proton and a neutron. On the outside you have an electron. Now this is showing you. See, it says the Bohr model of the atom with an electron making instantaneous quantum leaps from one orbit to another with gain or loss of energy, right? So this is showing you how they can manipulate electrons based on the amount of energy that's associated with it. But I just wanted to show you this so you kind of have a visual of what an atom looks like. It's basically like proton, neutron in the middle, electron on the outside. And remember I was talking about a free radical? This would be an example of a free radical, right? But some electrons, they don't move like this, and they're not able to be targeted like that, because that's different. Just all right, I apologize. I don't want to go into that because that's a whole nother subject I'm not really talking about. Just know that an atom is composed of a nucleus and one or more electrons bound to that nucleus, right? Only the most common variety of hydrogen has no neutrons, right? Remember I was telling y'all hydrogen has no mass, right? Because neutrons are what hold mass, right? I don't want to go too deep into this, but just know a neutron is a subatomic particle which has a neutral charge and a mass slightly greater than, my apologies, y'all. The neutron has a mass but no charge. Yeah, I'm wilding. I'm thinking backwards, right? It has a neutral charge, so it has no charge, but it has a mass, right? It has a mass slightly greater than that of a proton. So that's why in an atom, the neutron, this is where you get like a neutron bomb, right? When they make like a neutron bomb, because the neutrons themselves, they vibrate within each other and they explode the atom because the neutron has a mass, but the proton has a charge, right? You can look up neutron bombs and look up how they work, and then this shit will all make sense to you. Well, how they making this shit, how they making bombs and all of that. Like it's all quantum physics. All right. Let's go back to subatomic particles. All right. Now these are the particles that make up the particles that make up the atom. Right. Hence subatomic. Right. These are within atoms. Right. Now, in the study of nature, right, physical sciences, a subatomic particle is a particle that composes an atom. According to the standard model of particle physics, right, which is just some group or, you know, some like conference that they had to say this is what we're going to go by. The standard model of particle physics is a theory describing 3 of the 4 known fundamental forces in the universe, classifying all known elementary particles, right? And when you study electrons, you'll see that there are 4 different ways that they like numerically classify the charge and stuff like that. And I think that's what this is tied into, but that's not what that's about. I just wanted to show you that because you never want to skip any of these. You want to make sure you know what these are. And by the way, here's your reference for my people who need papers. That's, look, you know somebody out there is like, but that's Wikipedia. Okay, I got you. Here you go. Subatomic particles, NTD, archived from the original 16. So what you had to do is we had to go down. You had to go down. See, I'm taking my time. I'm taking time out from the lecture to cover these people who are going to be like, but he's on Wikipedia. He doesn't know what he's talking about. Get a book. So this is referencing an article. These are normally going to reference an article, right, that you can go into. I'm getting sidetracked trying to debunk the people who are going to try to debunk me. Wait a second. Hold on. So these are articles or international serial book numbers that you can reference to cover what we're talking about, okay? So I'm just showing this to the people who like, but I need a book. Go get this book. Elementary Particles, World Scientific, ISBN number, International Serial Book number, boom, okay? Go get those, all right? Go get your books, all right? Get your books, people. All right, but for people who want to learn now, let's learn now. All right, so according to the standard model of particle physics, a subatomic particle can be either a composite particle, right? And a composite particle is just a particle that don't move, right? An example of that would be like, well, not an electron because electrons move. Let's see what they say. My apologies. Why are you saying a list of particles? Why y'all not just saying what a composite particle is? What are you talking about? Okay, a composite particle are bound states of elementary particles. You see? So a bound state in quantum physics, a bound state is a quantum state of a particle subject to a potential such that the particle has tendency to remain localized, right? What that just basically means is the particle don't move, okay? The particle don't move, all right? And this is what I meant when I said they classify subparticles, because certain particles, what you say, son? Certain particles don't move, and these are examples of what they look like, and these are electrical bonds that they have with each other. I forget what these are called because they're named after some dude or something, but these are the bonds. It measures the tense or the strength between those particles. And once you figure that out, then you can start messing around with that and expand mass and make something grow. Like this is how you would make something grow 50 fucking feet tall. You know, this is how you would play around, play God right here. Like y'all gotta really understand how deep this shit is. Like this is not no games. Like this is how you control nature and everything. Like, you know what I'm saying? These letters are representative of, let me see if they say. So look, a composite particle proton is made of 2 up quark and 1 down quark, which are elementary particles, right? Now elementary, I didn't finish telling y'all, my apology. Elementary particles, right, are particles that move. So that would be like a electron, right? In particle physics, an elementary particle, yo, that's so messed up that they froze my live, because I don't think it's fair for me to be just running through this stuff, because I know people might have questions, but I'm gonna just go through it, and then I'll probably do another live if people didn't get it, or we'll just do another one that's gonna be more detailed. This is just gonna be a breeze through, right? And for those who are able to catch it, catch it. In particle physics, an elementary particle or fundamental particle is a subatomic particle that is not composed of other particles, right? Particles currently thought to be an elementary include electrons, right? Remember, electrons, right? So yeah, just know that electrons are elementary particles. We don't have to go too deep into this. Also, you want to know that a photon is, and what is photon? See, now we're about to get into frequency. Let's jump off this. I think okay, hold on. Okay, give me a brief break real quick, all right? I think I done touched on that enough for you to have a general understanding of what quantum physics is, all right? If not, we could go deeper, but I think you have a general understanding of what it is. All right, so photons. Stop playing with me. This tablet is about to mess up my energy. All right. No, it's not. Let me not cast spells. Nothing is gonna mess up my energy. All right. And if y'all want to know where this comes from, see that number 2 right there? When y'all searching, I'm showing y'all how to do research too. When you on Wikipedia, because I would highly recommend that you use Wikipedia. You're gonna be a goddamn genius. You use Wikipedia, depending on how much time or energy you have to devote to it. Most people are too busy worried about other shit that he can't learn. But if you have time and energy, you will become a goddamn genius on Wikipedia. Or you will at least know how to become one, because you can click on these links. Let's click on this too. Oh, god damn it. My fingers, y'all. My fingers. All right. And here's what you would do. You would get this book. International, stop playing with me, please. International Serial Book Number 97801 2415816. Universe, Human Immortality. You see this shit, y'all? Look at this shit. I ain't even know that. Human Immortality. They got a book explaining this to you. Now, remember I told y'all, look, I did a lecture titled The Food and Health Lecture, where I explained to you the reason why we are immortal. We are immortal because of primarily two. When you study biochemistry, right? I did a lecture on this. There's 2 processes that the body goes through. One of them is called cell proliferation, hence the preface or the prefix pro-life, right? Cell proliferation. The other one is cell death, or what they call programmed cell death, right? PCD. These 2 things work in tandem. Cell proliferation creates new cells that replace dead cells. PCD, or programmed cell death, kills off cells that may be weak. So you never die. You never die. Now, mind you, cells are made up of what? Atoms, right? Everything is made up of atoms and subatomic particles. The particles that we are made up of are called carbon. Let's keep going. All right? But I just wanted to reference that for my people who need books. Go get your books. Get your books. Get your books, all right? I'm not a book guy. I don't really do books. Cause see, when I do books, I can't do all of this. See, if you went and got that book going to tell you all about this, but it ain't going to tell you nothing about what's down here. And it ain't going to allow you to just quickly link to this. It ain't going to tell you about quantum excitation of a field. It ain't going to give you, you know what I'm saying? See, we could go, when you on Wikipedia, you could end up learning some shit you ain't even mean to learn. That's how Wikipedia is. Like, you really could get on here to learn one thing and end up learning everything about some shit you ain't even had plans on learning. Like, you'll be like, wait, what the hell is this? And then you go into it. That's how it work with me. That's how I get into so many things. But look, let's keep on going. So what is a photon? This is the sun. This is the sun's energy, by the way, just so that y'all know. Okay? A photon, my throat is starting to bother me. A photon is an elementary particle that is a quantum of the electromagnetic field. Remember I told you electromagnetic field is whatever the area that you're working with. And in this case, we're talking about electromagnetic, right? They're just talking about magnetism and electricity, which are basically electrons being carried or electrical charge being carried magnetically throughout a field, right? Including electromagnetic radiation such as light and radio waves and the force. Gerald, stop being so loud. You see me on the live. Come on, sir. Be respectful, okay? And force carrier for the electromagnetic force, okay? Photons are massless, okay, like electrons. Photons do not have mass, so they always move at the speed of light. That's why they move so fast, right? And they have very high frequency, photons, okay? So, now that we have a general understanding of what quantum physics is and what subatomic particles are and how they work and you have enough information to know how to find out more for yourself if you want to. Let's go ahead and move on. All right, let's move on to frequency, and let's start talking about the sky. Let's start talking about what's around you. Let's start talking about you. Start talking about why you're not supposed to eat meat. Start talking about how your body reacts, all of that kind of stuff, because now you understand quantum physics in terms of what it is, right? And metaphysics, quantum physics is like the study of nature on a quantum level. Metaphysics would be like the study of you on a quantum level. You get what I'm saying? Like quantum physics and metaphysics are kind of the same. It's just that with metaphysics, you're talking about you. Like you're talking about you, like your atoms, how it reacts to you, how your body, how this vessel, this vehicle works, right? And that's why metaphysics is considered a pseudoscience, because it's not something that first of all, it's not something they really want you knowing like that, because that's crazy for you to be knowing metaphysics. You become a danger when you know metaphysics. But it's still like something that they don't want to be practiced like that throughout the, like industries and stuff like that. So they make it a pseudoscience. And anything that's